So look at this exercise now, going over some of the equations that we have in the mathematics of wave, right? They say a transverse wave on a string is modeled with the wave function y of x comma t equals 0.20 centimeters sine of 2.00 meters to the -1 times x minus 3.00 second to the -1 times t plus pi over 16. So they say what is the height of the string with respect to the equilibrium position at a point x equals 4 meters and a time t of 10 seconds. So we want to find the y, the height of the string, the y coordinate of the string with respect to the equilibrium position, you know, at that x equals 4 meters and time equals 10 seconds. So they give us the equation. Remember that the equation or the function, you know, y of x comma t is basically this. It was one of the equations we discussed previously. Is equal to the amplitude sine of kx minus plus omega t plus phi, where phi is the initial phase shift. Now, what is the equation they give us? The equation they give us is this: y of x comma t is equal 0.20 centimeters. What is that? The amplitude, the sine of 2.00 meters to the -1 times x. What is this 2.00 meters to the -1? The wave number times x minus then 3.00 seconds to the -1 times t. What is this? The angular frequency. This 3.00 seconds to the -1 is the angular frequency plus pi over 16. What is this pi over 16? This pi over 16 is the initial phase shift, right? So what we have to do, we have to find when x is 4.00 meters and the time is equal to 10 seconds. So we want to find y of 4.00 meters, comma 10.00 seconds. So we just substitute the x that I have here and the t that I have here for those values. So we say 0.20 centimeters, the sine of now 2.00 meters to the -1 times x, that is going to be 4.00 meters. So the meters are going to cancel out, right? Minus 3.00 seconds to the -1 times the time, that is 10.00 seconds. So the seconds are going to cancel out, right? Plus the initial phase shift, which is pi over 16, right? So we can say that this is 0.20 centimeters. The sine of, as I said, the meters are going to cancel out because meter to the -1 times meter will be 1. And then we have 2.0 times 4.0, it would be 8.0, 8.00, right? So we get sine of 8.00 minus then second to the -1 times second would be 1, and 3 times 10 would be 30, plus the phase shift of pi over 16. So what you have to do, well, basically what you have to do is just to make sure that your calculator is in radians, because this is an angle in radians. This angle is in radians. So you have to make sure that you change your calculator from degree to radians. So when you change your calculator from degrees to radians, right, 8 minus 30 would be -22 plus pi over 16, and you put in the calculator -22 plus pi over 16 in radians, and you find the sine of that. That sine would be negative 0.1864. So you can say that y of 4.00 meters, comma 10.00 seconds. So y of x comma t in this case will be equal to minus 0.037 centimeters. So we know that the wave at this point, you know, or the string, right? It's just the wave that is propagating to a string. So the height of the string is below the equilibrium position because it's negative, and it's at 0.037 centimeters, you know, from this equilibrium position, right? So we have now a description in terms of the time and the x position, and what is the y position of the string.